Hello everyone, I'm Christina Joanna A. Nacario, and I am your first reporter.
Good day to all of you. My name is Dustin Neo M. Moral and we are the Group 5. So our group will be discussing about our topic, which is the geometric sequence. So please listen carefully and we're hoping that you can learn a lot from us today.
Good morning everyone, I am Princess Amy Harris, reporter number 3.
Hi, I am Roberto and Val, your 4th reporter.
So, hello guys, I am the 5th reporter.
So, what is geometric sequence? In mathematics, a geometric progression, also known as a geometric sequence, is a sequence of non-zero numbers where each term after the first is found by multiplying the previous one by a fixed non-zero number called the common ratio.
So, for today's video, we are going to talk about what is geometric sequence. We are going to find out how to find the nth term of a geometric sequence. But first, let's define what is geometric sequence. So when we say geometric sequence, it is a sequence with a common ratio. That is what we call a geometric sequence. So for example, 2, 4, 8, and 16 is an example of a geometric sequence. So the first term is 2, the second term is 4, and the third term is 8, and the fourth term is 16. So, since the second term is 4, it is obtained by multiplying the first term to 2. That is, 2 times 2 is equals to 4. So a third term is 8. The third term is obtained by multiplying the first term to the second term. That is, 4 times 2 is 8. As for the fourth term, the 16 is obtained by multiplying the first term to the third term. That is, 8 times 2 is 16. So, these two is what we call our common ratio. So, how do we find the common ratio? Simply divide the second term to the first term. So, 4 divided by 2 is 2. Or you can also use 8 divided by 4 is 2. And you can also use the 16 divided by 8 is 2. So again, to find the common ratio, simply divide the second term to the first term. So now, how to find the last 3 terms? To find the last 3 terms, simply multiply the last term to the common ratio. So, 16 multiplied by 2 is 32. 32 multiplied by 2 is 64. And for the last one, 64 multiplied by 2 is 128. Since we already know how to find out the common ratio and the last 3 terms, let us proceed to the formula of the geometric sequence. So the general formula of the geometric sequence is a sub n is equals to a sub 1 times r raised to n minus 1, where a sub n will be the last term, a sub 1 will be the first term, and n is the number of terms, and the r is the common ratio. So let's proceed to the example. So find the indicated term in each geometric sequence. So for number 1, our sequence is 6, 12, and 24. A sub 1 will be 6, which is the first term. R, which is 12 divided by 6, is 2, and our number of terms is 5. So we're going to use our formula. A sub n will be the last term equals to a sub 1 times r raised to n minus 1. Now, let us simplify. So we have a sub 5 equals to a sub 1 will be 6 times ratio, which is 2, raised to n, which is 5 minus 1. We have 6 times 2, 5 minus 1, that is 4. So that's why we have 2 raised to 4. Then 6 times, to get the answer here, you must multiply 2 4 times to itself. That's why 16. And for the last one, we must multiply 6 to 16. That's why we have 96 as our answer. So our fifth term is 96. That is a sub 5 equals to 96. As for the number 2, we have 1, 3, 9, and 27. A sub 1 will be 1, which is the first term, and number of ratio, that is 3 divided by 1, the second term divided by the first term, which is 3, and the number of terms, which is 6. Now let's use again the formula. A sub n will be the last term, equals a sub 1 times r raised to n minus 1. So we have a sub 6 equals to 1, which is the a sub 1, times the ratio, which is 3, raised to n, which is 6, minus 1. So we have 1 times 3, 6 minus 1, that will be 5. So again, to find the answer here, you must multiply 3 5 times to itself. That's why we have 1 times 243. Then, lastly, multiply 243 to 1. And that will be our final answer. Our sixth term will be 243, which is a sub 6 is equals to 243.
I am Princess Anne Mijares, and I have here another example of geometric sequences. So here we have 2, 8, 32, and so on. So our 2 is our first term, 8 as our second term, and 32 as our third term. And it is said that we need to find our ninth term and its common ratio. But first, we need to identify our a sub 1, r, and n. So a sub 1 is our first term, which is 2. R is our common ratio, which in order to get is to divide our second term to our first term. So since our second term is 8, we divide it to our first term, which is 2. So 8 divided by 2 is 4. And that is our common ratio. So what we need now is our n, or number of terms, which is 9. So next, let us distribute it to our formula, which is a sub n equals a sub 1 times r raised to n minus 1. And that's why we'll have a sub 9 equals, our a sub 1 is 2, our r is 4, n is 9 minus 1. Then let's simplify. So that we'll have 2, 4, and 9 minus 1 is 8. Let's simplify again. So we have 2 times 4 raised to 8. We're going to multiply 4 8 times to itself. That's why we'll have 65,536 times 2. Don't forget 2. So our ninth term would be 131,072.
So our next example or sequence is 1, -2, 4, and -8. So our goal is to look for the 10th term. So the formula, as we all know, the formula in looking for the number of term or the specific term that you're looking for is a sub n equals a sub 1 r raised to n minus 1. So our a sub 1 is equals to 1, which is the first term, and r is equals to -2, which is our common ratio, and n stands for 10, which is the term that we are looking for, or the number of term. So to begin with, a sub 10 equals 1 times -2 raised to 10 minus 1. So here we'll just simply subtract both the numbers, which is 10 minus 1. So a sub 10 equals 1 times -2 and 9 raised to 9, which is our answer in subtracting this particular number. So next is a sub 10 equals 1 and -2 raised to 9 is -512. So if you multiply 1 and -512, so our final answer is a sub 10 equals 2 -512. So again, here you just simply multiply 1 by -512. So this will be our final answer.
Find the sum of the first 8 terms of geometric sequence if the first term is 4 and the command ratio is 2. So guys, this is our formula. And then our first term is 4, and then the command ratio is 2. You can see here. And then our sum of the first is 8. So we're going to put it in our formula. Here, as you can see, I already put it. So first of all, we're going to answer this 2 raised by the power of 8. In order to get 256, we're going to do like this. 2 plus 2 is equals to 4. And then 4 plus 2 is equals to 8. And then 8 plus 2 is equals to 16. And 16 plus 16 is equals to 32. And then 32 plus 32 is equals to 64. And then 64 plus 64 is equals to 128. And 128 plus 128 is equals to 256. That's why it's 256. So we already have this answer. We already get it. And then we're going to multiply it. Going to multiply it by 4. Since our first term is 4, we're going to multiply it. So 255 times 4 is equals to 1020. Here. And then we're going to, since it's negative plus negative, negative times negative equals, it is going to be positive. So our sequence is 1020. You can see it, guys. And that's all. Thank you.